Hello everyone, welcome to mytutor.ng. In this video, I'll be teaching on the topic simple AC circuit. So what is a circuit? A circuit is a path provided for the flow of electric current. A circuit is a path provided for the flow of electric current. Or we can say that a circuit is a path along which electric current flows. So in today's topic, we are discussing a simple AC circuit. The word AC implies alternating current. Remember, there are two types of current: alternating current and direct current. What is alternating current? Alternating current is a current that varies periodically, a current that changes periodically, while a direct current is a current that do not vary periodically. So in today's video, we are looking at a circuit through which alternating current flows, and that's what we call an AC circuit. So by definition, an AC circuit is a circuit along which alternating current flows. So that is the definition of AC circuit. So we say that an AC circuit is a circuit along which alternating current flows. So, by definition, an AC circuit is a circuit along which alternating current flows. So, we defined alternating current as a current that varies periodically, that changes periodically. Alternating current can also be represented by a mathematical equation. So, the mathematical equation that represents an alternating current is written in this form, that I is equal to I naught sine 2 pi ft. So this is a mathematical equation that is used to represent an alternating current. The I is called the instantaneous current. The I naught is called the peak current or the maximum current, or also called the amplitude current. The F is called the frequency. Now, if you take a look at this formula, we can see a parameter there, which is the 2 pi f. We know that angular velocity is also equal to 2 pi f, that our angular velocity is equal to 2 pi f. So this symbol, omega, is called the angular velocity. So with this representation that angular velocity is equal to 2 pi f, if we substitute omega into this equation, then that will give us that our current, alternating current I, is equal to I naught sine omega t. So our 2 pi f has been substituted or replaced by our omega. So that means that we now have two equations that represent alternating current. This first equation, that I is equal to I naught sine 2 pi ft, and the second equation, that I is equal to I naught sine omega t. Omega t is called the phase angle. So omega t is called the phase angle. So this is a mathematical equation representing alternating current. So let's talk about alternating voltage. and a mathematical equation that is used to represent alternating voltage. Alternating voltage can also be represented by an equation. So we want to look at equation representing alternating voltage. So our alternating voltage is represented with a mathematical equation that V is equal to V naught sine 2 pi ft. So this equation is exactly similar to alternating current, where our V here is also called the instantaneous voltage. Our V naught is called the peak voltage, or the amplitude voltage, or the maximum voltage. Then our F is the frequency. Also, if you recall, we said that 2 pi f is equal to our angular velocity, that our angular velocity omega is equal to 2 pi f. So if we substitute omega, which is equal to 2 pi f, into that equation, then we'll now have the second equation representing alternating voltage, that V will be equal to V naught sine omega t. So that gives us the two equations representing an alternating voltage. And recall, we said that our omega t is called the phase angle, which is in degree. So this is a mathematical equation representing alternating voltage. So let's see how we can apply this mathematical equation in solving some questions. So let's look at an example on how to solve question involving alternating current or alternating voltage. The question on the board says, consider the equation V equal to 2 sine 1000 pi t. Find the peak voltage. The second question, we should find the angular velocity, and the third question says we should find the frequency. So we are given this equation, we are asked to find the peak voltage, the angular velocity, and the frequency. So let's see how to solve this question. So we'll start by writing out the equation we are given. We are given the equation that V is equal to 2 sine 1000 pi t. So, having written out the equation, then the next thing we need to do is to write out our alternating voltage, the equation representing alternating voltage. So we know that the equation says that V is equal to V naught sine 2 pi ft. So this is the equation representing alternating voltage. Now, to solve the question, we will do what we call you compare the two equations. That's why we have written it below the equation we are given, so that we can be able to compare the two equations. So what I mean by comparing means that whatever we have on this side should be equal to what we have below. So this V is equal to this V, and these two should be equal to our V naught in that order. So the first question says that we should find the peak voltage. So if we compare the two equations, we know that the peak voltage is our V naught. So our V naught, which is the peak voltage, is equal to 2 volts. So by comparing, V naught is our peak voltage, and what we have on our equation, which is where the V naught is supposed to be, is 2. So the peak voltage is equal to 2. So let's see the second question, angular velocity. We're asked to find the angular velocity. To find the angular velocity, we need to write out the second formula for alternating voltage. The second formula says that our V is equal to V naught sine omega t. So this is where we have the angular velocity, our omega. So if we write out the equation below it, the equation we are given, that v is equal to 2 sine 1000 pi t. By comparing the two equations, we can see that where we have our own angular velocity, which is the omega, is where we have our 1000 pi. So that means that our angular velocity is equal to 1000 pi. So to solve this question number 2, which is the angular velocity, we can see from this equation by comparing the two equations that our angular velocity is equal to 1000 pi. So we now have that our angular velocity is equal to 1000 pi. And remember, the unit for angular velocity is radian per second. You can leave your answer in pi, or you can multiply by the value of pi. We know that the value of pi is 3.14. So you can multiply your 1000 by 3.14 to get your answer, or you can leave it in pi. Now, to solve the question number 3. Question number 3 says that we should find the frequency. So to find the frequency, we'll go back to our the first equation. So we'll use the first equation that we write out to find the frequency. And by comparing the two of them, we can see that our 2 pi f is equal to 1000 pi. So writing it out, that 2 pi f is equal to 1000 pi. So we're looking for the frequency. If we make our frequency the subject formula, then we now have that our frequency f should be equal to 1000 pi divided by 2 pi. So this 2 pi goes over to this side to divide the 1000 pi. So on dividing, our pi will cancel out the pi, and our 2 will divide our 1000 to give us 500. Therefore, our frequency is equal to 500 Hz. So this is how to solve the 3 questions. The first question says we should find the peak voltage, and our peak voltage is 2 volts. Then the second question says we should find the angular velocity, which gave us 1000 pi radian per second. And the third question, which says we should find the frequency, which is equal to 500 Hz. In the next video, I will be teaching on the topic root mean square current. So keep watching as I take you along this series in this topic called simple AC circuit. So if you have enjoyed this video, please click on the like button, and don't forget to subscribe to our YouTube channel to get notification whenever we release new videos. So see you in the next video.